Alright guys, welcome to Professor Shemba, and today we are going to be looking at differentiation using first principle. Differentiation using first principle. So how do we differentiate using first principle? So it's a very simple thing. It's a very simple thing and very simple, trust me. So for example, let's say you have something like this. Now y is equals to 2x squared plus 3x minus 4. And what you have to do is to differentiate this using first principle. So it's a very simple thing. What you are going to do is that you are going to put y plus change in y as y, and x plus change in x as x, which means that anywhere you see y, you put y plus change in y, and anywhere you see x, you put x plus change in x. Do you get it? So let's go. Now here I'm having y, so it's going to be y plus change in y, then which is equal to, I'm having 2, then here I'm having x squared, so it's going to be x plus change in x, you put the square on it, so this is assumed as x here, then plus 3 into x plus change in x, then minus 4. So the next thing you do is that you open the bracket if necessary. So the next step is you open the bracket, so it's going to be 2 into, so when you open the bracket, that is this, when you open this bracket now, it's going to be x squared plus 2x change in x, then plus change in x square, you can see it, then plus 3 into x plus change in x minus 4. So now you simplify further as 2x squared plus, when you multiply through by 2, you are going to multiply through by 2. 2 times 2 will be 4x dx, and change in x, then this time should be 2 into x squared, then plus 3x, then plus 3 change in x minus 4. So the next thing you do is you take y, you make sure that you are left with only change in y here. So what you simply do, you simply subtract negative y from here, and you subtract negative y from here, so it cancels out this one. So you are going to have change in y will be equals to 2x squared plus 4x change in x, then plus 2 change in x squared, then plus 3x plus 3 change in x minus 4 minus y. So you have change in y will be equals to 2x squared plus 4x change in x, then plus 2 into change in x squared, then plus 3x, then plus 3 change in x minus 4, then minus, what is your y? Your y is 2x squared plus 3x minus 4. Then change in y will be equal to 2x squared plus 4x change in x, then plus 2 change in x squared plus 3x plus 3 change in x, then minus 4 minus 2x squared, minus times plus will be minus 3x, and minus times minus will be plus 4. So from here you discover that x squared, 2x squared minus 2x squared will be equal to 0. So you have change in y will be equal to 4x change in x, then plus 2 into change in x squared, then plus 3x minus 3x will be equal to 0. So you are left with plus 3 change in x, then minus 4 plus 4 is equal to 0. So you are left with change in y is equal to 4x change in x, then plus 2 change in x squared plus 3 change in x. Okay, so what you do next is you divide through by change in x. So divide through by change in x, that's what you do next. You divide through by change in x. So I'm dividing through by change in x. So I can simply say change in y over change in x is equal to, now change in x into, or I can simply say 4x change in x over change in x, then plus 2 changing x square over changing x, then plus 3 changing x over changing x. So you discover that this cancel out this cancel this, then you're left to changing x, and this cancel this. So therefore changing y over changing x will be equal to what? Will be equal to 4x plus 2 changing x, then plus 3. So at this junction, what you simply do, you say take the limit. So you take the limit of everything. So now in taking the limit, you say the limit of changing y over changing x as changing x approaches 0 is equal to the limit of 4x as changing x approaches 0, then plus the limit of 2 changing x as changing x approaches 0, then plus, then I take the limit of 3 also. So now if you take the limit of this, you are going to have dy dx. So the limit of change 1 by change is dy dx. Then taking the limit of this, taking the limit of this, it simply means that when I say change in x approaches 0, which means that anywhere you see change in x, you just put 0 apart from this one. So now here you discover that there's no change in x, so you simply write your 4x, then plus, now notice that there's change in x here, so it's going to be 2 into 0, then plus the limit of 3 as change in x approaches 0 is 3, because there's no change in x here, so you simply write it. So therefore your dy dx is equal to what? 4x plus 3. So it's as simple as that. So look at the second example. Y is equals to the square root of x, and you have to look for this. So it's simple. What you simply do, don't forget the principle. Anywhere you see y, you put y plus change in x, and where you see x, you put x plus change in x. So that is how to solve it. So here I'm going to have y, which implies that y plus change in y will be equal to square root of what? Of x plus change in x. You see? So which means that y plus change in y is equal to what? Square root of what? Of x plus change in x. So don't forget that the next thing you do is what? You collect the like time. That is, you simply put y, you take y here. So your change in y will now be equal to the square root of what? Of x plus change in x. Then if this one comes to this side, it becomes negative y, like what we did for the other example. So change in y will now be equal to square root of x plus change in x, then minus, what is your y? Your y from the origin, the question is what? Is root x. So now at this point, what do you do? So what you do next is divide through by changing x. So as you can see, I'm dividing through by changing x. So I'm having my change in y by changing x, which is equals to the square root of x plus change in x minus root x over change in x. So at this point, what do you do? So what you simply do is this. It's very simple. You just need to simply say you multiply. You simply say here you have square root of x plus change in x minus root x over change in x. So what you simply do is just multiply by square root of x plus change in x, then plus root x, then over. You repeat the same thing, then plus root x. So you know it's still the same thing, because this we cancel out this, and you are left with this, so it's still the same thing. So the reason why you are doing that is in order for you to eliminate this change in x from the denominator, so that it will not be undefined when you are taking the limits. So take note. So you have change in x over change in y will be equal to, now when you multiply these two, you are going to have x plus change in x. That's when you multiply. Then this multiplied by this is going to be plus square root of x into square root of x plus change in x. Then this multiplied by this will be minus root x into square root of x plus change in x. Then this multiplied by this will be minus x. So over divided by this multiplied by 0, that will be change in x into square root of x plus change in x plus root x. So change in y over change in x will be equal to this one minus this one, then you are left with change in x, then this will remove this, then you are left with change in x over change in x, then into square root of x plus change in x, then plus root x. You discover that change in x divided by change in x, you have 1, change in x divided by change, you have 1. So therefore, your change in y over change in x will be equal to 1 over square root of x plus change in x plus root x. So the next thing you do is you take the limit. So taking the limit, so when you take the limit of this, you are going to have the limit of change in y over change in x as change in x approaches 0 will be equal to the limit of 1 over square root of x plus change in x plus root x as change in x approaches 0. So this will give you the y dx, which is equal to, you have change in it, just put 0. So that's going to be 1 over root x plus 0, then plus root x. So which is equal to 1 over root x plus root x. So therefore your dy dx is equals to 1 over 2 root x. So that is that.